We're told that this is the graph of f, and the graph consists of a semicircle and 3 line segments, and then we're also told that g is the function given by g of x equals the integral from -3 to x of f of t dt. And we're asked to find the maximum and the point of inflection on g. Well, we don't have the graph of g, but we have to remember this relationship here that they share is really, really important. Why? Because if we know that g of x equals the integral from a constant to x of f of t dt, if we find the derivative of both of these, this illuminates a relationship, which is that g prime, the derivative of g, is f. They are the same thing. And so because they're the same, this graph of g is also the graph of f, this graph is also the graph of g prime. And so that means when they're asking us to find a maximum for g, we need to find where g prime changes sign. And specifically, since we're finding a maximum, we want to find where it goes from positive to negative. Well, we don't have g prime, but we do have f, and f is g prime. So we have to find when does it change sign from positive to negative. That happens at the zeros. And so here I see, okay, this goes from negative to positive, so that's not what we want. At x equals -5, that doesn't count. Here at x equals 0, it goes from positive to positive, so that isn't, or sorry, at x equals 1, it goes from positive to positive. But at x equals 3, I see that it goes from positive to negative. And so we can safely say there's a relative max at x equals 3 because g prime, or f, changes from positive to negative at x equals 3. Because again, we care about the derivative, but in this case, this graph is our derivative graph. Now what about 2.2? We're asked to find a point of inflection. When we want to find points of inflection, we care about where the second derivative changes sign. So we care about where it changes sign. And remember, if g prime is the same thing as f, then g double prime of x is f prime of x. So that means we're looking at the derivative of this graph here. And I'll start doing this in a different color. We want to find where the derivative changes. And so I see the derivative of this function here will be positive because it's increasing, and then it becomes negative. So I see at one point, at x equals 3, or x equals -3, I see that we change sign. I also see here the derivative would be positive, and then it becomes negative. So at x equals 2. And then, where else do I see it? This one's a little harder to see. I see here, at x equals 1, it's negative, and then it becomes positive. So we want to find all the points where we have a point of inflection for g. We can name them now. G has points of inflection. Points of inflection at x equals -3, x equals 1, and x equals 2, because g double prime, or f prime, changes sign at those x values. The biggest thing to remember for these types of questions is this relationship up here, and I'll highlight it again. If we know that g of x equals this integral, we also know that g prime is equal to that function. And so because of that, we can do a lot more investigating and figure out where g has those traits even if we don't have a graph of g.